With every compute resource on campus, you are required to, obey the rules, so to speak, right? So we have this policy, SAP 2901, et cetera, et cetera. It is your responsibility to read, understand, and follow the rules there. Of course, I'm obliged to say so. On this particular system, the data that you transfer to it, if you have research data or any data of any kind, make sure that you follow these rules. It must be classified as university internal or public to be in the system. Anything else is not allowed. Anything else could get you in trouble. So please don't do that. If you want more information, you'll have this link. You can go see what all those DC 4 or 5 and what they really mean. There's even a tool on there that you can answer a few questions, and it will help classify your data so you know what you have. By and large, most of you probably have public data anyway, or just writing software that generates something which is totally valid, so don't worry about it. The department, the last section here, the department actually had this policy in effect for quite a long time, and it basically says that you may not use more than 4 nodes at once for longer than 7 days at one time, right? 7 contiguous days. We're really flexible with this, right? If you ever need it, just ask and we'll of course let you have whatever. The reason this is in place is there's no scheduler. There's nothing to stop you from just dominating the entire system and running it in the ground, right? So by and large, you guys have been excellent with this. I mean, everyone has been really cordial and nice and played well, and so I really appreciate that. The new system we get, this will not be a policy. We're going to have a scheduler. We're going to have some partitions set up and rules such that when you go to log on, you can see which one has which rules and where you can run things. I will tell you that the first probably 6 months of that is going to be a test to see how it works. So there's going to be some where you're like, why am I running for 15 minutes in this stop? This makes no sense, right? So there might be some of that. It won't be 15 minutes, but. For the policy itself, if you don't have the slides handy, every time you log on to R1, you should see this screen first pop up on the terminal. It does remind you at least of the SAP, so you can go find that on the A&M main website. Also, when you log in, you'll see the message of the day. This has changed a lot over the years, especially with the combination or the merger of arts and science and everything. We're now obliged to maintain this sort of new patch schedule where every month, it used to be the first Saturday of the month, I think, we would reboot every node at 8 a.m. And the new schedule is the 3rd Thursday of the month, so it's easier to remember. And so we still have to reboot every node. When we get to the new system, that will also change. We're going to go to a biannual schedule where we'll actually reboot the machine twice a year unless something forces us to do so, right? So if we have a 0-day patch, some security issue we have to take care of, then we have to reboot and we'll let you know. But by and large, we'll plan on every 6 months, January, June, January, July, whatever it is, for the new one. Currently, we're stuck with this at least until we get rid of the machine in May. And I will talk more about how this cluster was going to go away. The other part of this that's interesting is we do list some of the versions of things that have been installed. This does not change often. The only one that really changes, I think, is R. And I installed R 4.3 last. I did not make it the new default. Henrik used to do this where every new version of something would become the new default in the system. And the problem with doing that with R, of course, is that every time I change the pointer for R, if you use it, you have to reinstall all your libraries. So I probably don't think you like that, right? You guys like to use the old stuff and not to change every time there's an update. Also, I don't do the incremental patch updates, right? I'll just do a minor version update and, of course, every major version that comes out. This will also change in the new cluster. The new cluster will use something called modules, where you guys can specify when you log in in your bash profile or what have you, which modules you want to use, which include versions. So if I install a new version, you don't care, right? If you want to use it, then you can do something about it. But yeah, so that's what that is. Oh, I did add this finally, so to let you guys know for sure. So it tells you the dates of the current patch, when it's been done, and then when to expect the next one, right? So October 19th is our next patch day. Thursday, roughly between 8 a.m. and 10 a.m., the machines will go down and come back up. Hopefully all of them will come back up. Also, when you log in again, the reminder of the 7 days and 4 node policy. Again, you guys have been really great, and I do appreciate that. The load command I mentioned, for those of you who've been using the system, if you want to know where to run your jobs, Henrik provided us with a script that is load, and it will list out all the systems and what their current usage is effectively. So if you see something with zeros in there, that's a node that you want to target for your jobs. See something that's got a big number, if it says load is, well, something bigger than 6, but then you'd probably want to leave that one alone. And there is a reason for this. On these systems, they're set up in a very old way. and they don't have protections for the main system when you max out the memory. So if you overload a system, the out of memory object, out of memory service will start killing things. And sometimes that's stuff that you need, which means that you can take down a node by overloading it. It doesn't happen often, but it does happen where you guys will lose a node. And so whoever's running on that node, when someone has maxed it out, everything stops in that node. Okay, so avoid those that are already in use as best you can. If it does get too full, let me know. Right? If I'm not keeping an eye on it or whatever else, then come to me and we'll figure out how to accommodate you. This also tells you some of those that are dead. I can show when we get to a prompt, I'll run it and show you. But one more comment about load. This is a custom script that was written by the previous admin. It exists only on this cluster. When you go out into the world and say, I'm a high performance computer person, don't tell them about the load command. They're going to look at you and wonder, what is that? Okay. By and large, when you're out in the world doing things, they all use schedulers anyway. So next semester, when we switch to the new system, we're going to try to get you all up to speed with that so that when you leave and move to other places, you're more marketable, you're more knowledgeable, right? You can actually get onto a new system and start using it and not going, hey, how do I SSH to a compute node? Okay. All right, so actually question, I know you guys have logged in. Does everyone here already have an account? Is anyone new to the cluster or? Everyone's new in the back, okay. So you have not logged in at all? No account, okay. Do you guys know how to use SSH? I see probably Windows machines. Any Linux users? One Linux user, everyone else is Windows? Okay. So we'll actually do this then. So in a prompt, you see this? Probably not. I unfortunately have this Zoom menu in the way here. Okay. So for Windows users, more than likely you're going to use something like MOBA Xterm or WinSCP or something like this to help get you there. But you can also do things through the terminal. And so by and large, in order to access the system, you need to use SSH. You need to specify the actual fully qualified domain name of this thing, which is in this case, the login node is r1.stat.tamu.edu. And of course, your username. You can do this two ways. You can actually use the flag-L to specify, or you can say Hielsberg, which is my net ID, @ and then the address, okay? Everyone familiar with that at least? Have used it before? Okay. Of course, it's going to ask you for your password. And then give you all the stuff we just saw in the previous slides. Is this legible? Everyone can read that in the back? Is that better? All right. When you log in the first time, well, when you log in every time, it should take you to your home directory, which is signified here. On this machine, you'll see a prompt that looks like this, which is your username at the system you're currently logged into. So when you get to a compute node, if you SSH in, you'll see like Z01, Z20, whatever it is you've logged into here. And then, of course, the path which currently exists, which tilde represents your home directory. Okay, good. If you want to know how much space you currently have, everyone has a quota. Okay, by default, the quota is 10 gigabytes, which is not very much. But the system itself has a total of 7 terabytes, so we're quite limited on this system. The new system, I think total raw space will be something like 90 terabytes, so I have a little bit more space to give you guys. But anyways, if you use the quota command, you'll see what you currently have, and then what your maximum capacity is. Actually, for the folks who are on Zoom, should I be using the cursor over here? Can they, because they can't see me in the room, right? I don't know how many people are online, but for the basic Unix commands, I'm not going to go through that here, but I did at least give you a link at the bottom. Here's a software carpentry page on using the shell. It's quite good. There's lots of stuff there. There are tons of resources online. You can Google for anything and you'll find something useful. More than likely, you'll end up doing something specific to your needs. So I'll let you have that. The next two slides just mean similar. How do you list the contents of your directory? For your Windows users, are you at least familiar with that part, or does anyone need some information here? Have we used a Linux machine other than that? Like, you're fine, I'm sure. No Linux experience though, right? Is that what I understand? Everything's, you guys are used to using the Explorer and Windows, we have to click and point and everything, is that right? Okay, so if that's the case, On the clusters, they're all Linux, which means everything's gonna be through the command line. There are tools like the MobaX term and so forth, or if you're on the Mac, you have CyberDuck or something where you can actually pull up and visually view your files and manipulate them that way, through SCP or SSH or SFTP or something like this. But when you're on the command line, you need to use the Unix commands. And so if you want to see the contents of your home directory, right, you'll use the ls to list, right? And say in my test directory, I happen to have these three things, right? 2 files, an executable, and a folder, okay? By default, they should be colored by some scheme. If you don't have the coloring, if you don't remember what this is, you can use a long view. We can do ls-s, and then here it'll give you the long listing of all the stuff. So here at the end, we have our file names, right? And on the very left-hand side, if it's a dash, this is a regular file. If it's a D, it's a directory, okay? I'll let you guys go to this page and look at what all of these things mean, but in general, you have permissions here, which tell you who can read the file, who can write it, who can execute it. So if it's an executable like an application, you need to have execute permission. If it's a folder in Linux, you have to have execute permission to go through that folder. It's a little strange, but that's how they do it. The number here is the number of soft links. Don't worry about that. The net ID here, the first column is the owner of the file. By and large, this will be you. The next column is going to be the group. This will also be your name, right? But you could have, if you had a shared project with somebody and you wanted to use a folder in your home directory that you have all the data in, you could create a group, or we could create a group for you, and then assign that group to this folder so that everybody who's in that group, whose user account is actually in the group, would have the permissions that are listed here to access that file or files, okay? And then the dates that follow after that are usually modification or creation time. So when was it last edited or when was it created? And of course, the spacing there I've sort of added just to make this a little bit more legible, but if you want to see the contents of a file, we can use the cat command. It's actually concatenate. And it may seem strange, but what you're doing is you're concatenating that with standard out. So you take the file and you're concatenating with standard out and it will dump it to the screen. So if I had a text file, a.text, that just had hello world in it, when I run this, you see it dumps it to the screen so you can see its contents. In Linux, if you want to delete a file, use rm. Be very, very careful with rm, especially if you download scripts from the internet. I have had acquaintances and friends even who've downloaded things that included things like rm-rf/. So rm-rf will remove, the -r means recursively, and the f means force. Don't ask my permission, just get rid of it. And the slash afterward is the root of your system. So if you have elevated privileges and you say rm-rf/, you've just destroyed your entire Linux machine, okay? So when you download things from the network or internet, excuse me, be very careful what it is and make sure it doesn't include junk like that. But if you do need to clean up your directories, you can do so. Just pay attention to what you're doing, especially if you're using -r, because that's recursive. So here we had our remove the A, and then we list it again. Now you can see that A is missing here. Again, check out the links at the bottom, and there'll be a lot more links throughout this, but. All right, so we did mention editing things on the other side, and I'll talk more about how to do that, but we have editors on the system itself. It's installed on all the compute nodes and the head node. VI is a very old one. It's my favorite. I use it all the time for everything. Even on Windows machines, I'll install Vim. I don't recommend it because it has a very steep learning curve, but it is extremely powerful. You can do tons and tons of stuff in VI, and you'll forget that you own a mouse. Like, it's pretty powerful. Nano is another one that's pretty simple to use. You open it up in the text, you just say nano and the file you want to edit, and then you can start typing away. It'll open up something that looks like this. We'll give some options here at the bottom. And so in this case, if I've had a blank file, b.text, I added some text over there, and now I cat it. You can see the text is out here, right? So enter text, Control-O in this case to save, and again, it's got some things here. And if you Google or check the help on that on the man page, for your Windows users, one of the biggest commands you should start using is man. It's man space and then give it another command. And it will go to the manual for that page and print it out on the console so you can see exactly what it does, what all its options are. Sometimes they include examples and everything, but man is your friend. You can also edit files through GUIs. So when you log in through SSH, it's all command line, it's text. But if we use X11, we can forward the graphics from the compute nodes or the head node back to your local machines where you can then edit them, right? So if we when we SSH in, notice the dash capital X here, This is telling us that we want to SSH with X11 forwarding. Now on Linux machines, this comes by default. On Macs, you're going to have to install Xcorts, and on Windows, you're going to need to use MOBA Xterm or one of these other things, I think, to initiate that, and they'll include the X11 libraries for you. But this -X, if you're on a command line on a Linux machine or a Mac or something like that, is important, and it will let you open up a window like this locally on your machine as opposed to in the command line or in the terminal. And so in this case, they have different editors. Emacs will also work in the command line, but it does have an interface that you can use with X11. So does gedit. Both of these you can use. And we said with the -X, they'll actually open up a new window, edit them, use your mouse, save, close it, it goes away, and all the changes will be made on the server itself, not locally. You're just editing through a window locally. And then here I got the links for MOBA Xterm and Xcorts, of course, if you need it. Oh, if we have time, I'll show a quick demo here, but MATLAB and Jupyter, MATLAB, is MATLAB the only example? Maybe so, but at the very least, MATLAB you can open up and you'll need this -X to get its whole interface to come through to your machine. Before we started this, someone was talking about VS Code. You can use editors like VS Code remotely. And so instead of initiating the editor on the cluster, you open up VS Code locally on your desktop. There's an extension you can download. There's the link, as well as instructions on how to get started. And then you can connect to it and start editing files. So if you want, I can actually show you. All right, so once you have it installed, and I won't go through the installation, you hit F1 to bring up the search for things like this. And you can see that I've recently searched for remote SSH, connect to host. And so this is the thing that you're going to install. We hit enter here. It'll bring up the list of machines that you have access to or that it finds in your SSH config file. So if you, on your system, especially on Linux and Mac, in the Windows world, it's a little bit different when you have MOBA Xterm and stuff because it manages these things. Sometimes it's nice to have to manage them in the same way that we do on the other systems, and so you'll get this. But for those of you that have .sh/config or /config, all the machines in there will get listed. Okay, and so here I've got r1.stat. If it's not listed, you can of course click on the add new SSH host, go through the little prompts, and now you can add your login to that. So let's click on this one. It opens up a new window for us and then asks for my password. Okay. Now, the left bar is collapsed here, but if I open up the Explorer, this is sort of the default for VS Code for those of you that use it. Just there's nothing open yet, right? We've made a connection to the server so we can actually do some editing. But if I want to view my home directory, for instance, I click open folder. By default, it'll show my home directory because it already knows what that is. Click OK. Now it's going to ask for my password again because it actually is making yet another connection. There we go. So now these are the contents of my home directory on R1, well, on the cluster, because the cluster has a shared file system. And then that file b.text we saw, we're in the example where we added this text, here it is. And so I can peruse I can add, remove files through the editor here or through the Explorer here, and of course, edit them as you will here. The nice thing about this interface, which is why I really like VS Code, is that all the other extensions that VS Code supports still work. So if you got linters or you're doing anything with code or anything fancy that you have, coloring, error checking, what have you, all that stuff will work and highlight your files or highlight and change whatever your files here, including auto completions, whatever. So when you close this, it should disconnect all of your stuff. However, they still recommend that you go to File and say Close Remote Connection. Okay, and that'll close you out for sure. I believe it should, yeah. It should still work that way. Worst case, you can create a file and then copy and paste through that, so the upload should work, yeah. All right, so this is more of what we just gone over. Oh, this little box in the top right over here, this do you trust? The first time you do this, it'll prompt you to make sure that you trust the authors of the site. This is your home directory. Hopefully you trust yourself. So for copying files, that's actually a very great question, because if you want to do it through the command line, you can use SCP. Chances are you're probably not going to do it this way. I do, but um, most folks now will use, if you're on a Mac, like CyberDuck or MobaXterm or any of the other ones, to just drag and drop what you need. So, um, but if you do want to do a purely command line way that you can add to a script or something like that, if you need to move files, this is what you would do. Mac users, actually for every system, but we have Samba enabled on this cluster. It will not be enabled on the next. It's sort of people use it for non-research things, and so we want to stop that. So we're not going to have it included in the next round. But for now, you can use Samba to mount your home directory and use it like a folder on your Mac or what have you. The equivalent would be on Windows to use the tools we've already talked about, right? MobaXterm, WinSCP. Linux users can use Samba. You need to have admin rights to do the mount, but you can do that. I don't have instructions for it here because no one has ever asked me for it, but that's something that's easily Googleable, or if you do, just ask and I'll help you out. Okay. Let me see, where are we at? Good. So I warned you, it's kind of a scatter shot, right? Is everyone doing okay? Screen sessions are actually quite important. Most of the folks on this cluster seem to like interactive sessions. In fact, even on HPRC, we see a lot of people that like to use interactive sessions. Does everyone know what I mean by that? So I have a terminal open and I run my application and I am looking at that standard out. I'm waiting for the next thing to come out. And if my terminal or my connection gets dismissed, closed, whatever, then I've lost everything, right? It's purely interactive. I am playing with my code as it goes. A screen session will help protect you in this because when you get disconnected through SSH, your screen session will still exist. And so all that output in your terminal and everything else is going to be protected and saved in the screen session, okay? So what we can do, all right, can everyone read both just so you can? All right, so I type screen, I hit enter, nothing happened, right? I have a new prompt. Doesn't look like anything's really interesting here. By echo hello, it's there, that's fine. Now if I want to disconnect, I hit Control A and D. And so now I've detached from my screen session. My output is gone there, but you see it tells me that I've disconnected or I've detached. If I were to log out and log back in, right, this would go away. Let's do that. All right, so my output's now gone, but if I do a screen-ls is list all your screen sessions. And so I can see that I still have a screen session that exists and it's in the state detached. We can reattach to it. And there's my output again, right? So if I have a running application here, all that stuff that's being sent to standard out is being saved here in the screen session. That process will persist even between logouts and logins and logouts, excuse me. If you have multiple screen sessions, you can certainly do that. You see that if you recall, this one had a name 161, whatever. I think it's the process ID and then some stuff. You can just create as many as you want and they'll all be uniquely named. That's not really helpful for you because you probably have no idea what all those numbers are and which was running in which. So you can create a named screen session, right? So now I've got still uses a process ID, but instead of having just this stuff here, it now has the name my app that I applied to it. And so I know that my app is in this one and I can reattach that specifically by doing the screen-r and then giving the name my app, right? So I can say, and now we're back, okay? Oops. So I do strongly recommend using that, especially if you're doing interactive stuff, simply since it does protect you from you know, my internet went out of my house and now I've lost my experiment, right? You don't want to do that. Oh, the last comment there is actually kind of important. Don't forget to clean this up. Make sure you exit your screen sessions. Quite often, it turns out that you guys will start screen sessions and then forget that they exist. And so we'll go on to clean up processes or check out the nodes and find half a dozen just empty screen sessions sitting there with nothing going on. So we do kill them eventually, but you know, yes.
The idea that like screen session don't just like a best practice or something.
If you are doing interactive stuff, then yeah, I'll go ahead and say it's the best practice. My preference, especially for computational things, is screen is helpful, yes, but really we should be using a scheduler. And in that scheduler, yes, you can create an interactive session. Like you can run bash as a scheduled job, but you should take input as from parameter files or some sort of inputs, and then you should be writing things to files. Okay. Everything should be without this terminal in mind. It needs to run on its own. It needs to be able to save things and be reproducible. And so I'll have some opinionated things about that later. But in general, screen sessions probably a best practice. If you're doing interactive stuff like that, certainly recommend it. But there are, I'll call it better ways. Sure.
If you're doing something interactive.
Sure. And if you're going to do something interactive and then you're connected to something, and let's say you're on your laptop, you close it and it disconnects your SSH session. Well, now it's gone, right? So that'll save you in this case. On this cluster, we have a number of packages installed, a number of software packages, various versions. We do have GCC installed. CentOS comes with some extremely old one. And so by default, when you log in and just type GCC version or -v, you're going to get like 6 or something ridiculous. If you want to use the newer ones, they are installed. You do need to source these files. So just copy and paste one of these for whatever version you need. You'll probably just use the last one. And you'll get GCC 11, for instance, okay? So if you are commonly using GCC, like is anyone actually writing software like C code or C++, anything else? What are we using here? I know we got some R users. What else is in the room?
We use C++ within R.
Within, oh, you guys are the ones I really dislike. Yes. Who was it? Somebody sent me a ticket where it was R using Java to run something in C++ or Python. We had 2 different kernels running inside R just to figure out how this was supposed to work. It was a little nuts. It did work though. It's just okay. So, anyways, what you can do so every time you log in, if you don't change your bash profile or anything, or your bash RC file, every time you log in, you're going to get whatever's there, which is going to be the base stuff. So we can modify your login shell so that, or your login, so your bash profile and such to include this line, so that every time you log in or create a new shell, it automatically runs that for you, and you have the tools you want. We do have Julia, although I don't think anyone in this room has ever logged in and used it. I think in the last 3 years, only one person has tried it once. There's that. For some reason, LaTeX is installed. I disagree with this. We shouldn't be typesetting our papers on the cluster. There are other uses for it, it's true, but in general, do that on a desktop, please. MATLAB is installed. It's an older version. Again, not many users, I don't think. Anybody using MATLAB? Anybody using? Okay, no. Python is on there. Well, we have a base Python installed. We recommend everyone use Anaconda. Okay. There are too many different variations of what people need for Python and stuff. And so on this particular cluster, install Anaconda. Anaconda is great because it actually will manage your virtual environments for you. So if you have some production environment where you're going to run Python 3.11 or whatever, and you have some testing things where you want to see what happens in 3.9, right? Then you can create those virtual environments. Anaconda will manage that for you, and you don't have to bother us with all the different things that go with that, right? You can install everything and it's set. So that's strongly recommended. It also gives you Jupyter Notebook. Anybody use Jupyter Notebook? Everyone know what Jupyter Notebook is? No one here? If you haven't used Jupyter Notebook, I recommend it. It's quite cool. You can use it so Jupyter was originally for Julia, Python, and R. That's where the name comes from. It has since expanded to support a number of languages, but effectively it's a online notebook where you get a set of cells, and those cells can be text cells or code cells. In your quote text cells, you can include Markdown, HTML, LaTeX, any number of languages for creating text or visuals. You can put pictures in there. And in the code cells, you can run Python code or R code or what have you live, right in the web browser. So when you create your document, your notebook, you actually run a kernel, And then you have your code live there and you can share this document. You can send it to people. If you don't want to set that stuff up on your own, or if you don't want to install Anaconda, you can go to Google Colab, search for Colabs, the Google Collaboratory, and they have free resources that you can just use. And it will access your Google Drive files and you just run what you want. For a long time, the Google Colab one claimed not to support R, but there was a magic URL you could put in that would give you R notebooks. They have since changed it for now. The default is Python, but you can now change the language. So definitely recommend looking at it because it is nice for sharing things. So if you have some R code that maybe generate some nice pictures or whatever you want to show to somebody else, instead of sending them your R script and say, hey, run this on your cluster, you can be like, hey, go to my website, run this, or download this and they can run it, or collaborate. So okay, this is important. The Stack cluster is a heterogeneous cluster, right? We mentioned it had 5 different generations of Intel processors, which means that they all support different levels or different types of microarchitecture. Like maybe one has AVX 512, but the rest definitely don't. They might have AVX 2 at best or something, right? So for that reason, we tell you to install and compile everything you need on R1. R1 is a virtual machine. It is set the default stuff to give you sort of the lowest common denominator. So if you compile it on R1, it will work on all the rest of the nodes. If you went to a compute node and compiled something locally, it may not work on all the other compute nodes, right? Depending on your optimization flags and what you picked. So recommend R1, it's gonna save you a lot of trouble. Compile and install R1. Running code, not on R1. R1's a virtual machine, it's tiny, it's meant for everyone to use. So if you need to run something, go to a compute node. So how do you go to a compute node? Well, we mentioned the load command. So here's the non-abridged version of that. The load command gives you output like this. You can see that in this case, Z2 was under heavy load and then most of the rest were at 0. So pick one of the ones with 0. You then SSH, SSH username at z1.stat.tamu.edu. And now you're on the terminal and you can just use that node as you will. Okay, you can do your interactive sessions, you can run stuff in the background, screen sessions, what have you. This is currently our quote unquote scheduler. You guys schedule via this, right? Again, if these get overloaded, they can fail, right? The new cluster will have a bit more protection installed for that. So we won't have to worry about it. But for now, we have to sort of play nice. So. Interactive stuff, we talk a lot about interactive sessions. And that really means sort of you're at the command line, you type command, see what happens, type command line, see what happens. You can, of course, use scripts. So we can create, well, in this case, I'm sorry, I'm talking here about redirects and stuff, but you can still use scripts. In this case, the files that I'm mentioning here are not batch files. These are the bash file descriptors. So for the non-Linux folks, you probably haven't seen standard in, standard out, and standard error. Those are file handles that are always open for you. Standard in is by and large your keyboard, right? That's the input that you do through the command line. Standard out is where the output goes. So when I had like cat a.text, the contents of that file were concatenated to standard out, which is my terminal that I see, right? Standard error is if I were to cat something that didn't exist. Instead of having standard out filled up with error messages, the error messages are sent to this separate file handle. And the nice thing about that is these are both sort of out, right? They're outputs, but you can redirect them to different places. So I can save the output without getting all the error messages or vice versa. And to do that, you can use these things here where I have, like in this case, I'm gonna take ls, which is gonna list the contents of my directory. I'm gonna take a vertical pipe, which says, take the output of this, pass it to this command, which in this case is gonna sort it. So alphabetically sort it. And then we're gonna redirect. I'm gonna redirect standard out to this file list.txt. So now I have in this file, which is probably a new file here, that contains, it is a new file, that contains the contents of this directory test sorted. Okay. So you can do things like that in your scripts. Yeah, so you can do that in your scripts. And then also we have some specialized files down here. Dev null, dev zero, and dev random. You'll see dev null quite often. People will say, I want to redirect standard out, but I want to take standard error and redirect it to dev null. Dev null is just like a black hole. Whatever I send there disappears. Okay. Dev zero is going to either accept and it'll produce zeros is one point. So you can actually take dev zero and pass it to standard in if you want to create a list of zeros, a whole bunch of zeros. Useful if you're taking I want to zero a drive or a file or something like that. You can actually use that to generate all those zeros and writing some sort of magic script that does it for you. Dev random is similar, except it does random bytes. So if you need random stuff, it'll use the systems entropy encoder thing to give you back a set of random things. So this is the slide I was expecting. All right, so instead of doing things interactively where you're typing one thing, waiting for the output and so forth, you can add all those commands to a script. If you create a script is just a text file. We typically start out with a shebang line. The shebang line is named because it starts with a hash followed by the exclamation point. So comic book days, the exclamation point was the bang, right? So, it got hit by somebody, so bang, and they would have the exclamation point. So shebang comes from hash bang or shebang. Following that is the path to the program that should run this script. So by and large, for bash scripts, you'll see /bin bash or some other version of that. If you're running Jupyter notebooks or something else like that, you can also have the path to Jupyter or whatever. And so in Linux land, when you run this file, you give it execute permissions and say run this. The first thing it does is read that line and then go get that application to run the file. Okay. Windows will ignore it. Windows uses the extensions, right, to figure out what program it should use and so forth. Mac is got a mixture depending on what you're doing. After your shebang line, you can put anything you would put normally in the command line. So in this case, I've got R command batch and then my file with my output save directory, right? And then I'm ending it with the ampersand. The ampersand is how you send a process to the background, right? So it'll run behind the scenes and you can still use the terminal in the foreground as you would. And then when you want to retrieve that background application or that process, you use the wait command. And so what this does is it's going to run these 4 lines in the background. So they'll all be running hopefully in parallel, hopefully. Well, not quite, but anyways, it'll run them as fast as it can. And then this will stop and wait until all 4 are finished. And after that, we'll write to the screen finished. This is echo finished. So I do strongly recommend that. Just sort of your question about screen and best practices. This, I would say, is the best practice. Script everything. If you're doing experiments where you've got lots of stuff and you're manually typing in with parameter changes and stuff, don't do that. Write yourself a script. That way, when you come back to it 6 months from now, you can reproduce exactly what your experiments were, and there's no problem. Okay. We have R installed, I mentioned. To start R, we'll use the R command. This is a symbolic link to one of the versions that are installed. Currently, that's 4.2.0. Okay. I'm not going to change that unless somebody tells me to. And by and large, in the next 6 months or 8 months, whatever it is, no one will tell me, I'm sure. But we do have other versions installed. And so, while I promise to keep this at 4.2, it's probably a good thing for you to just go ahead and write the full path to the version you want to use. Now, there hasn't been a whole lot of changes between 4.0 and 4.3, but if we happen to get 5 to come out, right, you don't want to have to move to 5 and then all your code doesn't work because of some breaking change the folks that are made, right? So put the path to the version in there. I would recommend that, but you can use this for short stuff if you just want to open up and start running things. I won't go through all these things. If you're an R user, you'll eventually find that, or you can Google for it. And so there's a lot going on there. So similarly with MATLAB, I won't show you much of that other than here's how you start it. MATLAB with no desktop will open up in the console, so you can actually just start writing without having all that interface going on. You just use the terminal. Non-interactive sessions, start MATLAB, no desktop, and then we're going to pipe in the file or redirect the file that you want as input, right? So this is your MATLAB script. All the commands get sent to MATLAB, all the output and so forth. You'll see these from the previous couple slides ago, get sent to this output file. And so now all my inputs are here, all my outputs are there. It's one line. There's not really, this is an interactive session because it's still in the shell, but if this is in a screen session or running it as a scheduled job, then when it's done, you'll just check the out file for your results. Sure.
I saw that the script that you were showing, you are running basically the same program but then specifying a different out file. So is it something
that may have just been laziness, actually?
I was just wondering, that is it like you're running the same code at the same time, but just returning 2 outputs at the?
In that case, yeah, it is just. Sure, you can run the program multiple times and have it output to different files.
Without having to change the R. file itself?
It doesn't make sense to do it, is more or less the point.
Yes.
Yes, so that's why I said there's some copy and paste in here. So
Okay.
the point is you can run many things in your script. No, don't do these one thing 4 times, but yes.
Sometimes we need to run the same thing again and again.
Sure. No, so if you're running something that has any sort of randomness to it, right? If you're running anything that has like, so maybe this thing reads from some other file in the system, right? It could be that it reads a file and then does something based on that. Yeah, I'm glad to know that you're paying that close attention though. That's great. Was there anything else on that or okay? So if you want to run the GUI session, you can do that. Make sure that when you log in with SSH, you use that -X and then just run MATLAB like normal and it'll open up the full display on your local machine. Okay. Have noticed recently that there are some problems. Here's how you fix them. If you start seeing some libgl errors in the console after you've run MATLAB, doesn't usually affect things, but you get this warning in your bash profile or just before you run MATLAB, you can export this macro here. You can define it to be 1, and it will tell MATLAB that it should use indirect rendering with libgl. Not that matters, but it fixes the errors when you get them. The next set of errors you see is sometimes with MATLAB, especially on the Macs, I've seen this, where it'll flicker or the white part will change black or it'll do some really odd graphic things. You need to actually specify how the rendering is done in Java. And so we need to create a Java ops file. Just put that in your home directory or perhaps the same directory that you're running MATLAB from, and then include these 2 lines. And then that fixes that problem. So just in case. Again, with the compiler, I'm gonna move a little faster here, but if you want to use the latest stuff, make sure you source the dev tools here. And then of course, if you're going to compile things, make sure you are using optimization flags like -03 or something like this. If you use Fortran or C++ users, you'll need that. For those that are using, I'm not going to go through this as an example because I only got about 10 minutes left, but if you're using like Jupyter or something in Anaconda and you want to get that web interface, so Jupyter is going to produce start a web server effectively, okay? And that's going to live on one of the compute nodes. Now, to access that web server, you have to do sort of some SSH gymnastics to get to it. And so this long line is going to get you there. Actually, it looks like 2 lines, but anyways, you're going to run copy and paste this. The port numbers here need to match across all the systems. And then you should probably change them. Don't use the same one. The system does have a finite number of ports. There's lots of them, but there's still a finite number. And we pick a random one here that should hopefully no one else will pick. So pick something that's large. So we don't want anything that's lower than 10,000, but don't go above 60,000. Okay, so you've got quite a few to pick from. Just make sure when you do this, they all match. You're going to log in. You're going to tell it basically we're going to pipe things from R1. Well, really from in this case, the node Z2, which I've chosen. You'll pick a node the same way you normally do. We're going to pipe all the graphics from that all the way back through R1 to our local machine. And if you follow the instructions here, you'll see the server will run on the compute node. You'll open up Firefox or something on your laptops or what have you, and point it to the address that's produced in the Jupyter Notebook output, for example. It's usually localhost dot, and you see that same port number that's here, and then some key that Jupyter needs. And when you do that in Firefox or what have you on your local machine, it'll open up the web server's contents on the compute node. And so you can do Jupyter or whatever that way. So, all right. I think we're getting close to yes. So I got 2 slides here on sort of best practices, and these are opinionated. The first one's sort of generalized stuff. Research or reproducibility in research is a big thing. Quite often, so I worked for A&M in research here for 13 years. And before that, I worked for the University of South Carolina for 8 years, both with mathematics institutes. I worked for TAMIDS, so the Data Science Institutes, the Institute for Scientific Computation, a number of groups over the years. And I have seen it happen a lot of times where a graduate student, a postdoc, a faculty member develops something, then leaves. And they hand it off to whoever's next. And the person that's got it next has 0 documentation, no comments in the code. They don't know how to specify the parameters, and they just go, I'm starting over. And so we got a couple years of effort and work that are thrown out so you can start over. So I say this to be, be organized, make sure that it's clear that if someone else picked up your work, hopefully they can just start getting at it. Document your stuff. Don't go crazy with documentation. That's very hard and time consuming, I understand, but do it. Parameterize your code. Don't hard code things. Don't manually type stuff in. Use scripts. Use variables for things, right? I don't care if it's a constant, if it's pi, don't write pi out. Use a variable. Especially in Python, use math.py or numpy.py, whatever it is. Keep all your configuration and parameters with your results. Okay. On top of that, I would even say keep your version control stuff. So use GitHub, right? Make sure that you have stuff in GitHub, because when you commit, here's my set of code. This code works. It has a unique commit hash that goes with that. You can take that, copy it, and include that in your parameter file, so you know exactly which code was used with exactly which parameters to produce exactly these results. So when it comes time to go to a conference and you have to rerun something, or you have a paper or a publication, you can with confidence say, this is how I did this. Okay. So again, my opinion, but I feel these are really strong and useful practices, and I think everyone should do it. We'll happy to debate that. But version control, GitHub is it. A&M pays for a special GitHub license. We have lots of tools there, lots of things. Here are some links for tutorials. GitHub Actions is a useful one. GitHub Actions can be used for things like, after I've committed my code, GitHub will automatically do stuff. It could be check your code, test your code, could be send it to my, my lab mate to go peer review it. It could do any number of things for you. And so there's a lot of opportunities for automation here and stuff that you can also use. Now, I know that it's time consuming. It's a lot of stuff to learn, but the little bit, if you pick up a little bit here and there, it can go a long way. So top one is even better, I think. Checkpoints. Interactive sessions, I frown upon them because you can lose things so hard. It's so easily, right? On top of that, if you're in a scheduled environment and someone preempts you, it means they stop your job, and now you have to restart it, right? Or something else happens, and even though you're saving your screen session, now you've stopped in the middle of some large, long-running process. How do you pick up where you left off? Or do you have to start? Like, say if this has been running for a week, do I need to take another week to get to where I was? Or if I checkpoint my code, can I restart pretty much right where it left off? Okay. If you're using variables, if you're using parameter files, if you're using all these things, and in, let's say, an iteration, you have some loop that goes on in your code. If at some point there you stop and say, I'm going to stop executing my code, stop doing my experiment, and I'm going to write the current state of my application to a file, right? Every variable I need to get back to this point, like where I am currently, dump it to a file. And then when you start your code next time, you can say, hey, start with these values and all of these variables, right? So it's a manual load or save of data, and then a manual reload of that data once you start back up. And so we call that a checkpoint. There are tools that will help you do that. So if you're like the PD folks often here at least use DL2. DL2 has built-in checkpointing. It'll checkpoint its data, the data that it manages for you. R, I think, yeah, here's a link to a package in R that actually does some checkpointing for you too. So there are opportunities there. You can find stuff that does it automatically, but I strongly recommend you take the time to do it, because it will save you massive amounts of time if your stuff gets stopped for whatever reason. The last one is testing. I won't go too much about this. I'm a strong proponent for testing. I think you should test everything. I've written massive amounts of unit tests, all of these different types of tests you can do. And I know that not no one, but it's difficult because it's time consuming, right? Often when you're writing your code, it's exploratory, right? You don't know where the endpoint is. And so to stop and test all these things that you may not use in the end is really hard to justify. So that I totally get and I understand. But at some point you will sort of say, this is what I want, this is what I need. How do you prove that it works? If you don't have a set of comprehensive tests that say, at least this function satisfies these preconditions and has these post conditions, I mean, what are we talking about? How do you write a paper and then justify that this is a true, thing? So I will say test as often as much as you are able. All right, I have 6 minutes. Cool. I'm actually happy to stay longer for any questions and things too, but I wanted to get to this part. This is the new machine that we've ordered. It is a nice machine. It's quite expensive. It consists of, we bought two of these guys. Well, actually, we bought 12 of these guys, but 2 of them are going to be used for the main file server and its backup. They each contain 2 Epic 7763 2.4 gigahertz, 64 core processors. So each of them will have 128 cores, plus the, the multi-threading aspect, but 128 cores plus a terabyte of memory. Okay. And then they will have mirrored terabyte, really fast, nice system disks, and then about 90 terabytes of raw NVMe space. NVMe, if you don't know, is a very nice, very fast SSD disk. They're quite expensive, but worth it in my opinion. We're also going to use the Rockport interconnect. So everyone knows what 1 gigabit, 10 gigabit, 40 gigabit Ethernet is, right? Anybody know what InfiniBand is? Familiar with this? So InfiniBand's been around for a long time. Mellanox and some other companies, but now NVIDIA owns it. InfiniBand is currently at 200 gigabits a second, I think. And the HPRC system, I think, has HDR 100, I think. So they have 100 gigabit a second interconnect between their systems. This one here, the Rockports, technically has 300 gigabits a second. It's all fiber. It's very nice. You get that through 12, 25 gigabit connections between every host. And we went with this particular one because it uses these kind of neat multiplexer switches, which require no power, no cooling, and it's completely hard-coded hard connected every machine to every other machine. It's kind of a neat setup. So if you're interested in knowing more about that, it's kind of cool. But anyway, so we have those for storage and backup. We have 10 more of the same 1U node we see there. Same setup, same processor, so 128 cores each, another terabyte of memory. We are including another 1.5 terabytes for scratch space. We may or may not allow, the goal is to give you the ability to write things to each individual compute node very, very fast. And so you should potentially be able to use that. We'll see how this plays out in the next few months with our discussions, but it's there. And then we have compute nodes or GPU nodes. We have 3 of these currently. They're the big boxes here. Same processor, 128 cores, another terabyte of memory, smaller system disks, but that's okay. You guys don't want to worry about that. The same scratch disk effectively, and then 6 of the Tesla A30 24 gig GPUs. HPRC has the A100s, which they have the older A100s, which are 40 gig cards. Still very, very good. These are a lower card, but there's such a huge price difference on them that in order to get 18 of these things, it was well worth to do this as opposed to probably 2 or 3 of the A100s. Okay. The current A100s that are out, I think, have 80 gigs now. So yeah, we can't even get the 40 gigs anymore. So that really affected the cost too. We mentioned this a bunch already, but here's sort of a quick summary of some of the changes. We are going to be using Slurm on the new one, so everything's going to be scheduled. You can still do interactive things, you just have to schedule it. We're going to be using modules. So this nonsense or this issue I talked about with having the R symbolic link to the whatever version, you don't have to worry about that because you'll just in your bash profile say, I want the following versions of these things, and then you'll have them. And if you want to update, then you can do that on your own. One of our goals is to mimic HPRC as much as we can. We would like it very much if you could start work on this cluster and say, no, I just need more nodes, and then copy it over and immediately start running. Like if we could get that set up where you can bounce between systems, I think that'd help you out a lot. And I think that would also be better for your future prospects, right? If you can go up and say, yes, I used this small cluster, but it was set up exactly the same as this other one, so I can go immediately step onto any big system you got and get, be productive. So that's one of our goals. We'll get there. We'll see. There's a lot of different things they offer, but we'll see what makes sense to the department, but it's the goal. No Samba access. So the slide I have with the Mac that logs in with this, you hit Apple K and go from there. That won't work anymore. We have some folks who use the cluster's file storage for department level things or non-research things. And so one of the goals, one of the reasons, one of the ways we're going to stop that is removing this service. Shouldn't be an issue. We can still use all the FTP clients. We're going to have Globus. You'll have lots of options to get things back and forth. So I don't see it as being a problem. Also, we're going to have more sessions like this specific to the new cluster to help you guys transition. I think, yes. So this is the last slide. I did want to include some things on HPRC. If you need an account, accounts are free. You can get one. They give you 5,000 SUs. That's 5,000 hours worth of compute. Sounds like a lot. It's not. You'll run through that in less than a month. You can ask for more. When you start asking for bigger and bigger numbers, you may want to go through whoever your, PI in your project is, or whoever your advisor is, something like this, because they start asking for not money, but paperwork. They want to know how those SUs were used. So you have to file a report every year and so forth. But the free accounts are easy enough, and you can get one and get started. They have training. Just go to hprc.tampa.edu training. You'll see several options there. They've got short courses, online courses. They have these primers that they have, which are really no different than the rest, but they have a different section. And then they do workshops. Excuse me. So the workshops are usually in person. Every semester, I think they run something kind of early the first month or so. And then they have some other resources here. Actually, this resource one is they have 3 clusters right now that are accessible. Maybe I think they have 5 clusters, but 3 that are the main ones. You have Terra, Grace, and Faster, I think. And so the description of what all those are is on the resources page. So, all right, so that was very fast. I'm sure. Told you it was a bit of a scattershot or whatever, but you will get a copy of all these slides. In fact, every time you get an account, or someone asks me an account, I just send them the latest version of these slides. It may or may not include the last bit on the new cluster, but the rest of it will all be there. So are there any questions online or otherwise? Is there anyone online anymore? Oh, good. I ran them off. Yes.
So there are regular reboots, so nothing running.
Good question. So if you have something that's running, and so you should be getting an email that tells you about this a week in advance. Plus, every time you log in, it's going to tell you the date. If you have something that you need to run through that time, email us. So we're to attempt to accommodate you in that. We're usually good about stretching out for a week or 2 like that, or maybe even postpone to the next month. But don't plan on getting 60 days on this machine. Okay. If you need something like that, then we need to really talk to HPRC, because they're set up differently than this one. The newer one, that'll be a little bit different. Like I said, we'll do that biannually, so hopefully that'll be less of a problem. But yeah, just let me know. Email ArtSci.
Okay.
So.
My last job,
I think it's it used to be Patch Tuesday in the Microsoft world, and then this group switched it to Thursdays because they wanted to have at least one work day afterward in case things got broken, they had to fix, and it wasn't a Saturday. We're all trying to figure out how to fix everything. So actually did pretty well time-wise. Any other questions?
2 questions.
Okay.
One is, I remember that at the very beginning, when I was trying to install some packages in R, there are some issues like maybe RStan or something like that.
Yeah.
Is there a way to bypass that, or is it like the best way forward is to reach out to you?
So it's actually a good question. So if you're having trouble installing something, definitely email us. So it used to be, before I switched over to technology services, if you guys had programming questions, I would just answer them, right? You can come to my office and we talk about it. The new job, we don't actually offer programming level services. And so there's a really, fine line somewhere between what I can and can't, what I should and shouldn't answer. But if you have a problem, email me, and then if it's too far across the line, I'll tell you, and then I'll give you a hint. But, I think in a lot of those cases, they weren't really programming issues anyway, but.
The other question that I had is a little bit operational question. So for example, if I'm running multiple scripts, they're very short timed, they are very, they require very small amount of memory, but it's not parallel. Maybe I'm running 10 of those on a single node. How far do I understand? How far can I go so that I don't overload it? I mean, is there a way?
Yeah. So when we start talking about scheduling in general, one of the things, even at HPRC, you have to, I guess it's way back there. When you write code, you should have an idea of what you're allocating, right? You should also have an idea of the runtime. Realistically, you've written an algorithm, you should be able to analyze that and say, this is, O of log n or whatever it happens to be. And then with your input, you know what n is. So you may not know all the constants, but you can estimate how long it should run, right? So we should do that analysis. No one does that. No one does it, but you should. And so you can estimate, I need 3 weeks or a month or whatever this is for this application. Now, sometimes that comes from the first time I've done this analysis, and now I say it's 3 weeks, right? Sometimes it also comes from experience where the last one took 2.5 weeks. This is about the same, maybe a little bigger, So for time wise, that's kind of how that goes. Usually people do it from experience and they use checkpoints. So if I know I'm going to say this should take 3 weeks, but could go a month. You know, if it gets killed after that 3 weeks, I still have my checkpoint. I can pick it up and run it for another week. So that's one part. The memory side of things, again, we should be able to analyze our code and say we're going to allocate these things. Now, with using all these other packages and other stuff, you don't always know what they're going to allocate, but you can do some tests and some small runs and see how it's going to go. I would say the other part of that, you know, probably the better way to do it is just experience. So pick a node, you know how much memory is in the node. Don't use 95% of it. Pick a number like 80%, right? If you're the only one running there, you can take 80% of the memory and the system should be fine. You could probably take 95%, but you know, and then run a few, check the memory usage, see what the peak is, and then go from there, right? That would be an easier way than sitting down and analyzing your code, but I still think everyone should analyze their code.
I asked this question because I remember one time I just scheduled everything in the node. The runtime was about 5 minutes,
Mhm.
30 parallel, and I just sent 4 of them. And you told me that you know, it's in queue. But by the time you emailed me, you also emailed back to me saying that, oh, it's already finished. So
Okay.
just
Yeah, I think that, yeah, I vaguely recall. I didn't know how long they were going to run is more the point. Yeah. Yeah. Okay. Yeah, these machines are kind of small. We have like just 12 of them that are at 64 gigs. All the new machines will be a terabyte. So we should have plenty of memory. And on top of that, when you use the scheduler, you'll schedule them all individually anyway. And you'll say this one is going to use no more than this amount of memory and this much time, right? And so the scheduler will say, I'm going to put these on whatever many nodes I want to and fill in all the gaps for you. So if somebody else is only using 90% of the node and you have jobs that take 2%, it'll just throw a bunch in there. If they take 5 minutes, then great. If they take longer, whatever. But the scheduler is going to help you in that regard. So, any other questions? Was this useful, helpful? Good, very good.
Let's start the speaker.
Okay. For those who don't have accounts, when you send an email, send it to artsci.tamu, and then I will send you a copy of the slides. For everyone who already has an account that wants a copy of the slides, there have been a few changes, but if you want copies, yeah, there. Just email the help desk or email me, whichever, and I'll send them to you.
Yeah,
I can do that too. I can do that if you like. Yeah, that's fine.
because we have a website where we post session, we are like uploading everything in the website. So
Okay. Okay, then I'll give you a modified. I'll give you the PDF that doesn't, because we don't want to put the last bit on there just yet. Do you guys want my opinionated best practices?
Yeah.
Okay, I'll leave those in there then. I'll send you an email.